Here I've got a couple examples showing how to combine multiple functions together. So we have the 4 operation methods: addition, subtraction, multiplication, division. And within each of these, as you can see, you can combine 2 functions together in order to get a new function. And so essentially, if you look, combining 2 functions through addition means just that. You're going to add those functions together. Subtracting means to subtract, and the biggest thing about subtracting is you have to remember the negative sign. So this negative sign would have to be applied to the g function. Multiplying is just that, multiplying. Most of the times you're either going to be distributing one function into the other, or you're going to be foiling them together. And then division, again, is straight division. But the biggest thing you have to remember here is that now your fraction rules come into play. And the biggest rule that we have with fractions is that your denominator cannot be 0. So here's the first example where we have f of x is x squared plus 3x minus 8, and g of x is 4x plus 5. And the first thing I want to do is f minus g of x, and then I want to do f plus g evaluated at 6. So a couple things to keep in mind is that this right here is going to tell you what you're going to evaluate by. So in this case, we're evaluating by x. In this second case, you are going to evaluate by 6. Evaluation essentially means what you're going to plug in after you combine. Okay, so that's what we're doing. So essentially, you're going to combine your 2 functions together, and then you're going to evaluate it by the rule set in place. So first and foremost, we're going to look at f minus g. And so to do that, it says we take our function f, so that's going to be x squared plus a 3x minus 8. And I'm going to go ahead and put these in parentheses to signify that that is just your function f. And here we're going to subtract, and then we need to do function g, which is 4x plus 5. Now with that, again, we need to take this subtraction sign and we need to distribute it through your back parentheses. So here, this is going to end up giving you x squared plus a 3x minus 8 minus a 4x minus 5. Combine it all together, we end up with x squared minus x minus 13. Now that we have found our combined function, the last thing we need to do is we need to go ahead and evaluate. So in this case, we're evaluating by x, so that would mean anywhere you have an x, you plug in x. Thus, we've finished our problem. With the other one, we want to look at doing f plus g. So again, we're starting with f, so x squared plus a 3x minus 8, and we're going to add this to the 4x plus 5. Now just like with the previous, we have to take your sign and you have to distribute it through your back parentheses. The nice thing about addition is that nothing changes. So this essentially is going to be x squared plus a 3x minus 8 plus a 4x plus a 5, which is going to combine together to give you x squared plus a 7x minus 3. Now we need to evaluate, and in this case we're evaluating by 6. So what that means is we are now going to do my f plus g evaluated at 6. So anywhere you have an x becomes a 6. So this becomes 6 squared plus 7 times 6 minus 3. So in this case, you'll end up with 75 as a result. So when you evaluate by a number, you have to do the math. You will get a number as a result. When you evaluate by a variable, you will have an expression as your result. Okay? Now, to make sure that there is no confusion, let's look at just one more here. One of the most important things to keep in mind, especially if you are dividing, is that you want to check your domain. Okay? So, the first thing that we want to do is we want to identify the domain of f, and then we want to identify the domain of g. Okay? So if we look at f, we have x squared minus 3. Because this is a square, what this means is that my domain is going to go from negative infinity to positive infinity, which essentially is all real numbers. Okay? Now we want to look at g. My g was 2x plus 1, which again is going to give you the domain from negative infinity to positive infinity. Identifying your domain in the very beginning again is very important. So the first piece we have is we have multiplication. So when we look at the domain of f times g, well, we have to put together your function. So we have f times g, which is going to be x squared minus 3 times a 2x plus 1. And in this case, what we're going to do is we have to FOIL this together. So here we've got x squared times 2x is going to be a 2x cubed. X squared and 1 is going to give you plus x squared. Then we have a minus 6x and a minus 3. When we look at this domain here, we are still going to be all real numbers because we don't have any radicals or rationals. So here this domain is going to be negative infinity to positive infinity, which means we can finish evaluating. So here we wanted to go ahead and evaluate. So we wanted to look at f times g and evaluate it at 2. So we can go ahead and plug that in. So we're going to have 2 times my 2 cubed plus my 2 squared minus 6 times 2 minus 3. So overall, this is going to end up giving you 5 as a result. Okay. Now the reason this is important is because my second piece wants me to evaluate my division at negative 1/2. So first, again, we have to look for the domain for f divided by g. So when we do that, we have to again set it up. My f was x squared minus 3. My g is going to be 2x plus 1. Now in this case, we have to remember the rule, which now says that my g of x cannot be 0. So in order to find the domain, again, we would have that my 2x plus 1 cannot be 0. So x cannot be negative 1/2. Okay. Now what that means is that my domain is going to go from negative infinity to negative 1/2 union negative 1/2 to positive infinity. Now the reason this is so important is because I wanted to evaluate by negative 1/2. So if you look at that, if I wanted to do f divided by g and evaluate by negative 1/2, in this case, this does not exist. And the reason is because negative 1/2 essentially fails the domain. Therefore, you cannot evaluate by it. Now, another thing that you can call this is you could also call this undefined, meaning that it causes a problem at that place. So this right here is the biggest reason why checking your domain, especially when doing the division piece, is going to be so important, is because you cannot evaluate by something that is going to cause you a problem. And clearly in this case, evaluating by -1/2 is going to give me a 0 in the denominator. Okay. So if you have any questions about combining functions together, please let me know. Otherwise, I do hope this video helped clear up any confusion or helped explain the concept in general. If you have any problems that are just really giving you a hard time, please feel free to send those my direction. I would love to try and help you navigate through them. Otherwise, I hope you enjoyed, and I'll see you next time.